Will need a blank piece of paper here shortly, so if you'd go ahead and get that out so that's ready to go. And last class we did the long division, synthetic division, and that was homework if you didn't finish it. So if you did not turn that in the Google Classroom, please come turn it in the basket before we get going here. Okay, and the handout y'all picked up is some practice questions we're going to look at from section 2.5. If you look over at the right side of the screen, our last big assessment is over sections 2.5, 2.6, and 2.7. So 2.6 and 2.7 are really graphing rational functions, and that will pretty much all be out of worksheets. But 2.5, we've got just a few questions. Looks like 11 book questions because we need a little bit more practice than what's on the worksheet. So that'll end up being 112, and I'll put that back up. Y'all don't need to try to get that all copied down right now. Okay, so section 2.5 is reviewing what is called the fundamental theorem of algebra. So it's something that I bet you remember, and by the name of it you can tell that it's important. You may not have been told what that is though. So the fundamental theorem of algebra simply says whatever the degree of your polynomial is, it's the same as the number of solutions that it has. Or number of zeros, same thing, interchangeable. Now sometimes these are real zeros, real solutions, and sometimes they are imaginary. But in total, you should have however many that matches up with the degree. So question number 1 is a quadratic. So we've reviewed this recently, so we're not going to spend too much time on this. But if it's a quadratic, that means it should have 2 solutions. Now, it doesn't mean that there's 2 real solutions. It doesn't mean that there's 2 x-intercepts, but there should be 2 times where this equals 0. So we've practiced all 4 of those methods recently, but my tend to go to is factoring. So feel free to try to factor it. It just doesn't factor. And the second one would be quadratic formula, of course, because it's the only one that always works. So again, I'm not going to spend too long on this because we've done it recently, but you need to know the quadratic formula. You need to know that b is -8. So -8 becomes a +8, plus or minus b squared minus 4. You need to know that a is 1 and c is 1. Plug all of those in accordingly. Be careful with the discriminant work. So as much as I tried to emphasize that, that still was a sore spot on your last test. And you guys even had a calculator, so you could have just typed it all in your calculator to double check it. But looks like that would be 60. And then if this breaks down at all, we should break that down. Looks like the square root of 60 is 2 square roots of 15. And then finally, every single term is divisible by 2, so we should do that. So this leaves us 4 plus or minus 1 square root of 15 over 1. So 4 plus the square root of 15 is 1 0, and 4 minus the square root of 15 is the other 0. But quadratic, so there's 2 solutions. 2 zeros. Okay, most of the rest of the questions we'll see. I don't know if there's any more quadratics. But have a similar purpose where we're trying to find the zeros or find all the solutions. But if it's not a quadratic, like question 2 is a 4th degree, not a quadratic, so you cannot use quadratic formula unless it's a quadratic. Now, there is a thing called a cubic equation, just like there's a quadratic equation, and there's a quartic equation, but I don't know if I've ever even seen it. I just know that it exists. It's pretty complex. So quadratic formula is not too bad, but the others are pretty unrealistic. So how we're going to ask you to find all 4 of these, and what I prefer to do is if I see that it's degree 4 and there should be 4 answers, I really like to see 4 blanks because that reminds me of what I need to have done before I move on. It will help you catch some of your mistakes. But these have to be rigged into one of 2 ways. Since you can't use quadratic formula, it either has to factor or we would have to give you a calculator. So this one factors. This is the difference of 2 squares. If something factors more, you should. There's another difference of 2 squares. And then you can set this factor equal to 0 and solve. There's one solution. Set this factor equal to 0 and solve. There's a second one. And then even though the sum of 2 squares doesn't break down, we can still solve this by subtracting the 4 over, taking the square root of both sides. The square root of 4 would be 2, so the square root of -4 would be 2i. And I kind of glossed over a very common mistake right here. So this is where it helps if you're really focused in on 4th degree. Should be 4 zeros. I only have 3, so I must have missed something. So you at least know to go back and look through your work here. When you take the square root of both sides, you have to do plus or minus. So not just 2i, but -2i. So again, if it's not quadratic, either it has to factor. By the way, the product sum method still works out fine if it's a bigger degree like this. That factoring method always works. Or we would have to give you a calculator. So let's look at that again with question 3. So can't use quadratic formula because it's not a quadratic. But let's see if I can get it with guess and check. X squared times x squared gives me x to the 4th. 48 be like a +8 and a -6 multiplies to -48. And if you FOIL that, you do get 2x squared. So that's how that factors. Again, feel free to slow down and do product sum. Product sum always works out fine. Okay, so if I set this equal to 0 and solve, this is a quadratic, so I can't just do it with a one step in my head. I actually need to consider subtracting the 8 over, taking the square root of both sides, don't forget plus or minus. Square root of 8 breaks down into 2 square roots of 2, but since it's -8, it should be 2i square roots of 2, and -2i square roots of 2. Okay, but that's only the 2 solutions that come from this side of it. There should be 2 more that come from this side. So I guess this doesn't really factor more, or at least not perfectly, but I do think you would be crazy to do quadratic formula here. That would be a lot of extra work. Just add the 6 over, take the square root of both sides, just don't forget plus or minus. 4th degree should have 4 zeros, 4 solutions. Now I know I've been bugging you about this recently, so I'm not going to sidebar and do this, but you know, if you had a calculator, or in our assignment here in a few minutes, if you didn't feel super great about any of these, you can store one of these in your calculator for x, type this in, and make sure that it gives you 0. Even the answers with I in them, you can store. It's like second decimal, I think, gives you that. Alright, so all 3 of these questions are pretty similar, so this would be a good time to get some clarification if you need it. Okay, and let's move on. So along the same lines, this is a 4th degree. We're just given different information now. Different information, so a different way it plays out. But if it's a 4th degree, in the end we need 4 zeros. It's not a quadratic, so we can't use quadratic formula. And unlike the last 2, this doesn't factor nicely, even with product sum, because this has so many different types of terms. You can't factor it. But what we could do is we could say, well, wait, we'll give you one of them, and then from that, there's a process that you can take to find the other 3. So first off, you need to know that imaginary zeros always come in conjugate pairs. So I would probably write that out if I was you. Imaginary zeros always come in conjugate pairs. So telling you 2 plus I is 1 is really indirectly telling you 2 minus I is 1 as well. We will for sure test you on that. Now, if there was some way for me to divide out one of these, I could take it from a 4th degree down to a 3rd degree. And then if I could divide out the second one, I could get it down from a 3rd degree down to a 2nd degree. And if I can get it down to a 2nd degree, then I know I could at least use quadratic formula as a worst case scenario. So then the question comes to, well, how do I divide these out? Unfortunately, we can't really divide out with imaginary like this with synthetic division. It just gets too weird and too messy. But what we can do is we can turn these into factors. So I'm just going to write out all 4 factors, because sometimes we ask you for the factors instead of the zeros anyway. And to go from a 0 to a factor, you just do x minus the 0 and distribute to minus. X minus and distribute to minus. Now, while this is really messy right here, what happens is if you multiply these 2 things together, if we distribute these, what's going to happen is we're going to have a quadratic that we can divide out of this and take it from a 4th degree down to a 2nd degree. So do x times all 3 of these, should give you 3 terms. And then distribute the -2 to all 3 of these, gives you 3 more terms. And then finally distribute the I, which gets us up to 9 terms. 3 terms times 3 terms should give you 9 terms. Now, this looks really messy for a second, but notice how much of this is going to clean up here. So plus xi minus xi goes to 0. Plus 2i minus 2i adds to 0. I've got an x squared. I could combine minus 2x with minus 2x to get minus 4x. And what about that? Have we reviewed this year? I squared? I don't remember if that's come up or not. Okay. Then you need to add this to your page here if you don't remember it. If I is the square root of -1 by definition, if I square this side to get I squared, it's like squaring this side. So I squared is -1. So minus a -1 is really like a +1. And I can combine that with the +4. So my thought process here is, I know factors will divide into this polynomial evenly, but if I divide by this, it's going to be really messy because there's going to be i's all over the place. Same with this. But if I turn these zeros into factors and multiply these factors together, these two things are saying the same thing. These are equal, but this is much cleaner looking. So finally, we can say, I really want to take this out of the original problem now space, which I can do with long division. So no coincidence that that's why we did this last time, so that this wouldn't be too much of your focus. So you go through the long division process. Now these are supposed to be coming from factors. Change the signs and add 0, 0, 6. And because these are coming from factors, I know that the remainder should be 0 in just a second. So if it doesn't, I can check my arithmetic pretty quickly. And looks like next would be +6. Oh, I messed this up right here. Like I said, I know that the remainder is supposed to be 0 because these are supposed to be factors, and that's what factors do. They divide into it evenly. Right here, 5 times x squared would be 5x squared. I did change the sign, but I didn't read it very carefully. This is supposed to be -4. So this should be -4. So -4 times all 3 of these. And then when you change the signs and add, I get the remainder that I was expecting. Now, how you're supposed to think to do this is you need to understand how this was helpful. What I did is I just stripped out 2 of the factors out of this really big complex polynomial that I had no way of being able to wrap my head around. And when I stripped that out, it exposed the other 2 zeros, and so then I can finish it a normal way. I just would do factoring by difference of 2 squares. So this pulls together a lot of different skills. You need to know that there's 4 zeros because it's 4th degree. You have to know that imaginary zeros come in conjugate pairs. So when we gave you 1, we really gave you 2. You have to know how to change those zeros into factors. Do x minus a 0, get you the factor. Just make sure you distribute the negative. Those are really messy, so we multiplied them all together to make it look like a much cleaner quadratic. And then dividing that quadratic out of the original one, expose the other part of the quadratic, which helps me see the other two answers. Oh, except I put these in the wrong spot. This would be the factor, so this would be the 0. This would be the factor, so this would be the 0. Okay, so a lot going on there, so make sure you have that all written down and speak up if you see something you want to ask about. Okay. Question 5 looks to be the same type of question, except it's a much easier version, but a lot of the same kind of thought process. So we probably should have done question 5 first. So this one says find the remaining factors. So if this is a third degree, it's got 3 zeros, which means it's going to have 3 factors. And unlike the first page, it's not quadratic, so you can't use quadratic formula. It's also not factorable, so you can't just do that. But the trade-off is we're giving you one of the factors. We're giving you one of the 3 that you need. So like the last question, if you divide out this factor into this cubic, it's going to leave behind a quadratic. And I don't know how the quadratic's going to solve, but I know even the worst case scenario, I can get the last 2 answers from quadratic formula if I need to. So you've got an option here. You could either do long division and divide by x plus 4, or I think what most people would do is do synthetic division but remember, this wouldn't be positive 4 then. It's where the divisor equals 0. So add down and multiply, add down and multiply, 6, 9, and that can't be correct because if this is really a factor, I better get a remainder of 0. So something in my arithmetic's wrong. 24, right here, 1428. Makes this -5, which makes this 20. So of course I wouldn't normally do the arithmetic part that quickly, but so the purpose of doing that division is to take it from a third degree, divide out the one that we know about already, lower its degree down to a quadratic, and then again we've got lots of options with quadratics. We've practiced that quite a bit more. I would try to factor it, and I'll just be honest, I don't know if it factors. -10 plus 3, yep, that's how it would be. So you could set each of those equal to 0 and solve if the question wanted zeros, but if it just wants the other factors, well, you've got the factors. So this big idea of if you know a 0 or a factor, you can divide it out, long division, synthetic division, lower your polynomial to a quadratic, and then you can solve your quadratic the same way we've been doing. So again, really the same as number 4, but number 4 is just like the hardest type of that question. Alright, switching gears just a little bit. Number 6 is kind of asking you to work this backwards. It says find a third degree polynomial function. So instead of you being told the function and go find the zeros, it's saying, hey, here's what the zeros are. Now you find a polynomial that would have those as zeros. And this is typically what we have to do for tests. We usually start off with what we want the answer to be, and then we do this process and come up with the function to give you to start off with. But if this is a third degree, shouldn't there be 3 zeros? Why are they only giving me 2?
Because they always come in conjugates.
Right, imaginary zeros always come in conjugate pairs. So telling you 6 minus I is 1 is automatically telling you 6 plus I is 1. So if we change these to factors, do x minus this, and distribute, x minus this and distribute. Now this would be factored form, and that's okay sometimes, but this one's saying real coefficients, so we can't leave it like this. So what we will have to do is we have to multiply this mess together to make it look like a traditional looking polynomial that's in standard form. So I would highly suggest that you multiply these two together that have i's in them first. So do x times all 3 of these. That gets you 3 terms. Then do negative 6 times all 3 of these. That gets you 3 more terms. And then finally I times all 3 of them. Three things times 3 things should give you 9 terms. I'm trying to color coordinate that to help you see where they're coming from. And just like the question from a couple problems ago, this looks really bad for a moment, but then all of this is going to clean up into a nice looking quadratic. Plus x squared minus x squared adds to 0. Plus 6i minus 6i adds to 0. We've got an x squared minus 6x minus 6x could be combined to be minus 12x. And because I squared is negative 1, this is like minus a negative 1, which is like saying plus 1. Add that to 36 and you get 37. Okay, so I multiplied these two things together and it cleaned up into these 3 terms. Still need to distribute this x minus 1 though. So x needs to be multiplied to all 3. And then negative 1 needs to be multiplied to all 3. And then combine like terms. In the end, I got 1x cubed minus 13x squared after I combine those two together. 49x's when I combine those two together, and then a constant of minus 37. That's a polynomial with real coefficients. The coefficients are 1, negative 13, 49, negative 37. Those are real numbers. That's why it matches the directions. So again, it's kind of backwards. Instead of starting with the function and you find the zeros, we're giving you the zeros. You got to turn them into factors and then multiply those factors together carefully to come up with the function. Now I do want to graph this one for just a second because I think there is some value. I know I have verbalized this a few times recently, but it is a little bit more important now than it was with quadratics. So since I know what the zeros were supposed to be, the zeros were 1, 6 minus I, and 6 plus I. You need to remember that imaginary zeros do not show up as x-intercepts. Only real zeros show up as x-intercepts. So I'm about to hit graph on this, and because he has 3 solutions, that's what the fundamental theorem of algebra tells us, that there's 3 zeros to this, but it doesn't tell us how many of them are real zeros. But since we started with that, only x equals 1 was the only real zero, so x equals 1 should be the only x-intercept. And then that confirms that. The other zeros are imaginary, and imaginary zeros don't show up on the graph. Yeah.
what is an imaginary zero then if it doesn't show up?
Well, just when we graph on the coordinate plane, like this is the x-axis and y-axis, so there's not room for imaginary numbers on that.
Okay.
So that's why it doesn't work that way. Like if, I don't remember what it was, but like if 6 minus I is a 0, like 6 minus I doesn't exist on the x-axis to be an x-intercept.
Okay.
So that's that reason. Now there is other type of graphing. I don't know if y'all did it or not. It's not that important, but you can graph numbers like 3 plus 4i in what's called a real imaginary plane. So you would just take the real number, tells you how far left or right to go, and then the imaginary number tells you how far up or down to go. But if you're not graphing on that type of plane, then it's not going to show up. So, all right, and then finally, the last one is not any different other than maybe the directions here. So when it says product, what does product mean? Product means multiplication. So we're supposed to find all 4 linear factors and show that they are multiplied together. So basically find the 4 factors, but instead of listing them with commas, have them next to each other. It's the same as when you do this. When you factor this, this is a product, because they're being multiplied, of linear because they're x to the first factors. So if I try to factor this guy, looks like we could do x squared times x squared to get x to the 4th. Minus 6 times positive 1 gives us negative 6 for the last part of FOIL. And the outer and inner part of FOIL combine to be minus 5 x squared. This can't be your answer though because of the quadratics. Linear means to the first power. These are currently quadratic factors, not linear factors. So if I set this equal to 0 and solved, I'm going to just find the zeros. I would add the 6 over, take the square root of both sides, so plus or minus. If I did the same thing over here, subtract the 1 over, take the square root of both sides, plus or minus. And if you have the zeros, you can just do x minus a 0 to get a factor. So x minus a 0, x minus a 0, x minus a 0. Now they're linear factors because it's x to the first. And I have them all set multiplied together, which is the product part. But really you just need to be sure that you understand what those directions are. Otherwise it's not different. Okay, so as you can imagine, some of these question types take more practice than normal. So with your blank piece of paper, let's go ahead and copy down the assignment, and I'll give you a few minutes to try the first couple questions. And I suspect we will want to look at several of these together. So put the assignment back up on the board. So go ahead and copy that down, please, and then try 9 and 13. Oh, I need to add that too. Those first two questions shouldn't take you but about 10 seconds each, so I'm not going to give you too long here. Some of these questions certainly are longer, but not those two. Okay, so let's check your answers to 9 and 13. And then there's one more thing I need to tell you too for the next two. It didn't come up on our practice worksheet. Let's see, so 9 and 13 both just wanted not for you to find them or anything, but just determine the number of zeros that it would have. Okay, so the number of zeros for, oh, I'm sorry, it's frozen. Number of zeros for 9 would be 3, because that's what the fundamental theorem of algebra tells us. If it's a third degree, then it's going to have 3 zeros. Same idea for number 13. The number of zeros is going to come from the degree. Now, if you go too quickly and you think that the degree is 1, that's not what the degree is. Because of this, if you have to, make yourself do x plus 5 times x plus 5. And when you multiply that together, it's going to be a quadratic. So quadratic is degree 2, so it's going to have 2 zeros. So first two were just about how many zeros should it have. Not are they real zeros, not how many of them are imaginary, just how many total. Always going to be equal to the degree. Okay, and then for 15 and 16, there is a part that I still need to tell you here. I need to review you on. Alright, the directions say use the rational zero test to determine the possible, and I can't emphasize that word enough, the possible rational zeros. So rational numbers are anything that can be written as a fraction, but that doesn't include imaginary numbers. And this is often referred to as the P over Q list. This is probably how you heard it in Algebra 2. You take plus or minus all the factors of P over plus or minus all the factors of Q. So that should land its question towards what is P and what is Q. P is the constant in the problem. So for us it's -2. But since we do plus or minus anyway, the negative doesn't really matter. So everything that goes in evenly into 2 would be plus or minus 1 and plus or minus 2. And Q is the leading coefficient. So that would be the number that's multiplied by x with the biggest exponent. So in this question, the leading coefficient is 1. So we need plus or minus all the factors of 1. This is what's called the rational zero test. So basically what it does is it gives you a list of things, and these are the only possible rational zeros. So if I expanded this list out, and normally we don't do this because it usually can be quite a bit of stuff, but basically any of these numbers over any of these numbers tell us what numbers could be zeros. So like +1 over +1, -1 over +1, 2 over 1, -2 over 1, and everything else is a duplicate. Now, these are not zeros. These can't all be zeros. This is only a 3rd degree. There's no way that it has 4 zeros. But of all the rational numbers, these are the only possibilities. So for example, 5 is not in this list, so there's no chance 5 is a 0. 10 is not in this list, so there's no chance that 10 is a 0. 2 is in the list, so 2 is possibly a 0. But what they wanted us to do in question 15 is to look at the graph and confirm that any rational zero that we can see from x-intercepts is on the list. So looks like it had a 0 of 1, which was part of our P over Q list. -1 was there, and -2 was there. So that's what they wanted us to confirm. Verify that the zeros in the graph are contained in the list. But really this is your answer. If you want to expand it out and write it as these 4, you can, but some of these lists are going to be pretty big, so you probably want to stick with this. Okay, so you try number 16. Same question type. Do the P over Q list, look at the graph, see if the information matches up. It should be either telling you you did something wrong or confirming that you were on the right track. Okay, so your answer for 16, to list out the possible rational zeros and to apply the rational zero test, basically same thing. We need plus or minus all the factors of p, which is a constant. So anything that goes into 16 evenly, plus or minus, over plus or minus all the factors of q, and q is the leading coefficient. So this is the answer that they were looking for, and we're going to use this in some of the next questions. This list tells me what of the rational numbers are possible. Again, 5 is not in this list, so there's no way that 5 is a 0. There's no way that 5 is an x-intercept. 3 is not in this list, so there's 0% chance that 3 is an x-intercept. But 16 is in the list, so 16 might be an x-intercept, and negative 16 might be an x-intercept. Yes? Right.
How do you get a zero?
How do you get p? P is always going to be the constant. So the part without an x. So plus or minus all the factors of p. Anything that goes into it evenly. So what they wanted you to do, now notice, if I listed this list out, there'd be 2, 4, 6, 8, 10. Yeah, there's 10 possible zeros. That doesn't mean this function has 3 zeros. The fundamental theorem of algebra tells us that there's only 3 zeros, but these are the ones that are possible. Now notice this list is never going to tell you what imaginary zeros are possible, just rational numbers. But they want you to look at the graph and see that 4 is actually a 0, and they want you to see that 4 is in the list. Positive 4 over positive 1. They want you to look and see that 2 is actually a 0, and confirm that 2 is in the list. Positive 2 over positive 1. And negative 2. Negative 2 over positive 1, also in the list. So they're trying to help you see that visual connection with the P over Q list, the possible rational zero list. Okay, I think that's the last one that's specifically like that. So, y'all have any questions about that? Did you do this P over Q list in Algebra 2? I feel like it's not been coming up as much, but it did used to show up on the ACT, and again, it is like a 5-second question if you know how to construct it. So, and we'll talk about why we need it here in just a second. But next up, I would like you to try the next one, which is 31, but I will give you a hint that for 31, you need to start with a calculator. Specifically, you need to start with the graph. So let me give you a second to try to figure that out, and then I will help you.
There might be something wrong with my graphing function. I typed in like, those are O's by the way. So I typed all in.
Yeah, you gotta have X's. Where are your X's?
I have something programmed in as X. Would that affect it?
Mm-mm.
Okay.
No. Basically, what you're typing in there is it's just doing all that arithmetic, getting a number, and then it's graphing y equals whatever that number is, and that's why you're getting a horizontal.
Oh, I see.
Yeah. You need some variables in there so that it changes over time. Okay, so my hint of using a calculator and graphing, this is what you should have gotten out of this. Well, first off, it says find all the real zeros of the function. So this is a 4th degree. So I know that it has 4 zeros. I guess technically I don't know that they're all real zeros, but there could be up to 4 answers here. Now, when I graphed it, I'm not going to graph it very accurately because I think you should have it in front of you as well. It looks like I don't know, something like that. So what part of the graph is going to be useful in this question? Okay, so like I'm pretty sure if I do trace 1 enter, it confirms that 1 is actually an x-intercept. X-intercept is when it equals 0, which is why they're called zeros. So with the calculator, that is easy to extract that one. Now this one looks like it might be at a half. Don't just guess and hope that that's right. You can do trace 0.5 enter to jump to that point, and if you do that, you see it's not exactly the x-intercept. So this is something else. This one I'm unsure about. But over here it looks like it goes exactly through -3. Again, just do trace -3 enter and it jumps to that point. At the bottom it should show you -30 as a point. But then over here it looks like there might be one at about -4.5. If I do trace -4.5 enter, that's not quite. So I don't know this one either. So the graph was helpful because it gave me 2 of my 4 answers. It also gives me an idea of how big the other 2 should be, but you've got to be more specific than that. You've got to get it down better than that. So like we did in our notes, if 1 is a 0, you could either synthetically divide by 1 or long divide by x minus 1. And that's going to take it from a 4th degree down to a 3rd degree. So add and multiply, add and multiply. You should know the remainder is going to be 0 because this is coming from a 0. 10, 6. Also, I think, did I tell you all synthetic substitution last time? If you pair up these 2, it tells you a point on the graph. Okay. So,
why is it not -4? Or I was thinking.
yeah, the factor would be x minus 1. So if you're doing long division, you would have to divide by x minus 1. If you're doing synthetic division, it's where it equals 0. Now, to be honest with you, this is not much better. This was started as a 4th degree. Dividing out one of them gets it down to a 3rd degree. But I'm not much better with 3rd degree stuff either. But the good news is I have a second one that divides into it. So don't divide into the original polynomial. Divide it into the 3rd degree one. Do synthetic division a second time, or long division if you really want to. And since this is a 0, it also is supposed to have a remainder of 0. So we've got a little bit of a check. Now, what's left here, this is big, because now this represents 1x squared plus 4x minus 2. And unfortunately, it looks like we're going to have to use quadratic formula to finish this question, but we still went from not being able to find these exact values on the graph to 2 minutes later, now we've got a process that we know will at least work. So opposite b plus or minus square root of b squared minus 4ac all over 2a. 16 plus 8 would be 24. 24 would be like 2 square root of 6. And then divide them all by 2. Looks like the other two are negative 2 plus the square root of 6 and negative 2 minus the square root of 6, which I would have never guessed. But if you still have your graph pulled up on your calculator, you can type these in. Do negative 2 plus the square root of 6, I'm sorry, trace. If you hit trace negative 2 plus the square root of 6, enter, it will jump to that point, and you can see for that x value, y is in fact 0. So it confirms that that's true. And then if you hit trace negative 2 minus the square root of 6, enter, it jumps to the other point, and it confirms that was the other x-intercept. So as long as we can see some of the x-intercepts exactly, enough that we can get it down to a quadratic, it doesn't matter how messy those last two are, because quadratic formula can always finish the last two for us. Okay, 33 is asking you to do a few of these things, and then it's kind of similar. So, do the P over Q list for part A, sketch a graph in part B. You can just do that in your calculator. Some of your answers should be automatic, just like these two were automatic from the x-axis. And then in the end, find all the zeros. So, if you can't see them all as x-intercepts, you have to divide them out, divide them out, divide them out, until you get down to at least a quadratic, and then solve your quadratic. So go ahead and start 33, and I think 37, yeah, 37 is basically the same thing too. So if you feel good with 33, you can move on, and if you don't, we'll go over it here in a few minutes, once I think you've had time to try it. So 33 is an odd one, so if you checked your answer and you're comfortable with what you're doing, you can tune me out here and just move along. But this will be the last one I'll look at with you on the board today. I think the next one is similar, and then the last four match up with the notes pretty well. But we can also discuss them together next time in class as well. So you'll have class time to do them or most of them, but not time for us to go over them also. Okay, so for in 33, the first thing it wants is the possible rational zeros. So it's really asking for that P over Q list. So plus or minus all the factors of the constant divided by plus or minus all the factors of the leading coefficient. That's what it was looking for in part A. Any rational number not in that list cannot possibly be a zero. Part B said to sketch the graph. So we're just going to use our calculator here. Looks like it goes through -1, -2, and 2. But I'll need to be sure that it's not just close. So trace 2 inner confirms that 2 is the x-intercept. Trace -1 inner confirms that -1 is a 0. Trace -2 inner confirms that -2 is a 0. Part C, find all of the real zeros. Well, from the graph, I can see 3 of them, -2, -1, and +2. Now, the last question, I would have synthetically divided this to make this a lower degree, and then synthetically divided this to make it a lower degree, and then synthetically divided this to make it a lower degree. This question was just less work. It was a 3rd degree, so in the end, it can only have 3 zeros anyway, so all 3 of them were found on the graph. We didn't need to do any division to lower the degree and make the question manageable. So obviously that's best case scenario. That's what you're always hoping for. You're always hoping that you can see the zeros from graphing it. Okay, so what I'd like you guys to do, you've got about 15 minutes left, so if you would please try to finish the last 5 questions, and if you don't finish those, then please try them for homework. Just to be clear, our 2.5 quiz is not next class. We'll still have one more class together on this, so part of what we will do next class is go over the rest of these questions. But you need to try them yourself first so that you can see what you really understand and what it is you need to focus on. So.
43 would you multiply x minus 2 twice?
Mm-hmm.
Okay.
Because if you only do it once, you're gonna have your answer is gonna be 1 degree smaller than it should be.
So this would turn to positive 25, right?
Mm-hmm.
Okay.